Hello, in this video I will show you how to perform non-parametric tests in R. I will cover the Wilcoxon Signed Rank Test, Wilcoxon Rank Sum Test, and the Krusal-Wallis Test. Basically the non-parametric one-way ANOVA test. Okay. So question, when do we consider the use of non-parametric tests? So basically, t-tests solve all the problems when data are normally distributed or sample size is large, based on central limit theorem. Okay, even though the data is not normally distributed, but we have large sample size and we're comparing the means, the sample mean will follow a normal distribution. Okay, so we will consider non-parametric tests when the sample size is small and the data are not normally distributed. So here, several other remarks I want to make. One is non-parametric tests are based on data ranks. So we basically rank the data from small to large. So that's why non-parametric tests are usually not sensitive to outliers. Okay. For null hypothesis, non-parametric tests compare medians instead of means. Okay. Also, Wilcoxon Signed Rank Test is similar to paired t-test. Wilcoxon Rank Sum Test similar to independent sample t-test. Krusal-Wallis Test is similar to one-way ANOVA. Okay. All right, so let's go to the R codes. Set the random seed for reproducibility. So for Wilcoxon Signed Rank Test, let's generate a pre-treatment and post-treatment data. So basically, we need a paired data. So this is a pre and post study design. Then we put pre and post into a data frame. So this is the first few rows of that data frame. Okay, so the next step is to perform the Wilcoxon Signed Rank Test. We will use the R function Wilcox.test. Okay, and for the Wilcoxon Signed Rank Test, we need to specify paired equal to true. So we tell R this is for paired data. Okay, so and we can put pre-treatment and post-treatment data set in the first two arguments and then paired equal to true. Okay, so we can print out the results. It tells us the name of the test and the data is a pre-treatment and post-treatment and the test statistics and then the p-value. And since this p-value is very small, so we reject the null hypothesis, we conclude there's a significant difference in the medians pre and post-treatment. Okay. All right, and the next part is we show Wilcoxon Rank Sum Test, and this is similar to the independent sample t-test. So we have to have two groups which are independent, and they don't have to have the same sample size. So we generate group of 1 for 25 and then mean 60 and standard deviation 10. Group 2 is also 25 and mean 65 and standard deviation 12. So here we have equal sample size, but it doesn't have to be. For example, group 2 can be sample size 35 or 40, okay, so let's combine the scores and then the groups into one data frame. Now this is what our data look like. So it has scores and it has groups. It should have group 1 and group 2. Okay, so this is the structure of the data set we're working on. And to perform Wilcoxon Rank Sum Test, we use the same R function Wilcox.test, and we put group 1 and group 2 in there, and then now we specify paired equal to false. Okay, This is important because we are telling R, do not treat the data as paired, treat it as independent. So we are performing Wilcoxon Rank Sum Test. Okay, and then print it out. So similarly, the test is Wilcoxon Rank Sum Test. This is the exact test. Okay, and get the test statistic and the p-value, and this p-value is 0.42, about 0.43, so still below 0.5, and reject the null hypothesis, and there's a significant median differences between the two groups. Okay. All right. The next one I want to show you is the Krusal-Wallis Test. So this is a non-parametric one-way ANOVA. So it's testing whether there's a significant differences among the medians in 3 or more groups. Okay. Well, let's generate group 1 and group 2 and group 3, and put them together. And this is the first 6 rows, and you can see it has scores, and then group should have 1, 2, 3. Okay, 3 groups. To perform the Krusal-Wallis test, we can use the R function Krusal.test. And we kind of use the syntax like a regression model. So scores tier.group here, and data equal to data. Okay. So we run that and print it out. It gave us the title of the test and the Krusal-Wallis chi-square test statistic and the degree of freedom, and the p-value is 2.6 times 10 to the negative 5. So this is a very small p-value, so we conclude there's a significant difference in the medians of the 3 groups. All right. So I have demonstrated how to use R to perform Wilcoxon Signed Rank Test, Wilcoxon Rank Sum Test, and the Krusal-Wallis Test. Thanks for watching.